This year in M229, our group was presented with a problem. Our partially paralyzed client requires a device operable by head movements and fit to her wheelchair, which will allow her to independently turn the pages of a variety of books. Although there are a few automatic page turners available, none meet our client's specific needs. Existing page turners are expensive, complicated, or run off of multiple motors. After discussing and refining the problem statement and doing some initial research, our group came up with a list of functions, constraints, and objectives.
For design ideation, we brainstormed numerous design alternatives. Then we discussed each one and narrowed the list down to 4 main designs. The 4 design alternatives were all similar, featuring ways of rolling or grabbing the top page and then flipping them with a separate arm or system. For design selection, we ranked all of our objectives using a pairwise comparison chart. Using these rankings, each objective was assigned a relevant weight. Then, the design alternatives were put through the gauntlet of the weighted decision matrix. The rubber wheel design reigned supreme, with the highest score, and was chosen to be the best solution to the design problem.
After we completed the initial drawing of our chosen design, we recognized several potential issues with our device. The initial design had no way to maintain the force between the rubber wheel and the page, leaving the team questioning whether the wheel would be able to roll the paper up effectively. In addition, our design did not allow the page-turning mechanism to adjust for the decreasing height of the book as it was read. When considered in full, the team felt that the initial design was overly complex and failed to meet all of the specified constraints. The final design consists of 2 independent pieces. The first is a wooden base designed to lay atop the wheelchair tray and angled at 30 degrees to increase operator comfort during reading. A movable ledge is used to support the book to ensure the mechanism will work with volumes of various sizes. Elastic straps secure the book to the base and facilitate easy setup. The second component of our design consists of the page-turning mechanism itself, which is free-floating and guided by 2 dowels running through the angled base. The weight of the mechanism is supported by the 3/4-inch rubber drive wheel, which is in constant contact with the book. When turned, this wheel rolls the page up, which is then flipped from the top by the rotating arm. The arm then rests atop the flipped page, preventing it from flipping back across the spine.
Our analysis examined the normal force required for the rubber wheel to slide the page into a position where it could be properly turned. This friction analysis revealed that rolling without slipping would be difficult to achieve. However, even with a small amount of force, around 1 Newton, the page would quickly match the speed of the wheel so it could be pulled into the correct position. We learned a lot from this design project. First and foremost, it is never too late to alter or completely change a design to better solve the problem. Our design was constantly evolving, as we noticed other aspects of the problem it could not account for. Sometimes a design idea is also a lot more complex than it initially seems. For this reason, it's important to work out some of the key details before selecting a design alternative, as this may change which one you select. Most importantly, teamwork makes the dream work. It would have been impossible to create this design without our amazing group.